All right, so what I asked you to do, I asked you to kind of go through here and see how much of this review sheet or this conclusion page, summary page that you could do, and then we're going to walk through that real quick, just as just a quick little spot where you can look at some things. All right, so let's start over here. Let's start about all the little characteristics of the sine graph. What's the period? What's the amplitude? What's the domain? What's the range? So what's the period? 2 pi, that's correct. Amplitude, 1. Domain. Now, in general, it's all real numbers because this sine cosine graph does go indefinitely to the left and to the right. All right? But a lot of times they're going to give you a domain. They're going to say from 0 to 2 pi or 0 to 4 pi or negative 2 pi to 2 pi. Okay? So a lot of times they'll give you that because if not, you could just keep spitting out answers nonstop. Okay? And then the range. Make sure we list the little one first when we're doing it, but -1 to 1, yeah. So
if they give you that, like how you said 0 to 2 pi, what is the domain still be all real numbers or it would change?
no, you would list that. Mm-hmm. If they gave you the domain as 0 to 2 pi, they're probably not going to ask you a domain question then.
And what would the domain be then?
0 to 2 pi, because that's what we're doing. So we would work on the domain that they gave us. All right? So they're kind of restricted. Okay? Tell me about a sine sketch. Where does it start? Starts at the midline, at the origin on this one. Goes up, goes down, back to there. So there's a sine graph. Okay? Everybody okay with it? Okay? If we go to the next, if we go to cosine, what about the characteristics for a cosine graph? It's 2 pi, 1, all real numbers. It looks almost identical. We don't really tell those apart. What's the difference between a sine graph and a cosine graph? One starts at the top, one starts on the midline. It's a phase shift difference, so they're off by 90 degrees. So a cosine starts up there, it ends up there, all right, and it would look something like that. So in the middle right there at pi, it would be at its low point, okay? Remember, everything's very symmetrical here, so if I go high point to high point, the low point is in the middle. It's between the two high points, okay? So that's cosine. Everybody okay on cosine? All right? Now tangent's a little bit different. So what is the period for tangent? Pi. It doesn't really have an amplitude. It's more applied in a vertical stretch manner. That's kind of what you were asking about. Well, the rough was about it's going up 1. So there's a 1 there. There's a vertical stretch of 1, right? Now tell me about the domain.
It's all real but that.
All real except the asymptotes. That's correct. All real except the asymptotes. The first asymptote that we come to normally on a normal tangent graph is pi over 2. So it's all real numbers except x cannot be pi over 2. And then we said plus or minus pi n. What's the pi doing there?
It's every other.
It's the period. So if I have an asymptote, then if I use the period, then every period, all right, then I have another asymptote. All right, so pi over 2 plus another pi plus another pi. You can go in a positive direction, you can go in a negative direction. That's fine. Okay? Now, if your period changed on the problem, then your domain would change here with this pi as well. It would match whatever the period is in that problem. Okay? The range, all real numbers. Okay? Tangent graph. It's a little bit like a sine graph because it starts there in the middle. So that's 0. That's on the midline. At pi, we see another one of those inflection points. Is kind of what we referred to that the other day. Same thing at 2 pi, we'd see another reflection point. Where are my asymptotes? In the middle of those. So from 0 to pi, at pi over 2, we'd see an asymptote. And from pi to 2 pi, we'd see another asymptote in the middle, which would be 3 pi over 2. And then what we would do is we could say, okay, between that inflection point and that asymptote, if I went halfway, I'd go up 1. If I go halfway, I'd go down one, halfway I'd go up one, so forth, and there would be my tangent graph. Okay? I haven't seen very many tangent graphs on the IB test. Doesn't mean that they can't be, but they're a little bit harder to apply than sine and cosine, so we see a whole lot more sine and cosine graphs than we see tangent graphs. All right? Doesn't mean I don't want you to know how to do that. So once you know how to do that, go from there. Okay? Everybody good there? All right. So I'm going to add to our notes right now. So you got a blank page on the right-hand side. You can go work on that blank page right there as we're going. So I'm going to try to kind of put a couple things together for you as we go, and then we'll do an application problem at the end of the day. Okay? All right. So we have this right here. Cosine of double x, cosine of double angle is equal to cosine of x. All right? I want to solve this. I'm going to solve this in a couple different manners, all right? A couple different representations. Kind of trying to draw some of the things that we've been talking about, like Unit 1, Unit 2, Unit 3, trying to draw those together, all right? So how could we solve this graph or solve this equation?
Use the equation for the double cosine.
Okay, so we could go back to what we did last unit. We used the identity for the double angle. And so this one right here, we could change this. Most of us look at that and go, okay, I like that. That's easy. That's pretty simple. This one we look at now, it's not quite as simple. The nice thing about cosine of a double angle is how many options did we have? There's actually 3 options there. Sine, we only have 1 option. Cosine, we have 3 options. Which option am I going to take? I'm going to take the one that has cosine in it. Okay? So that option would be 2 cosine squared x minus 1. Some of you might have gone, I already forgot that. That's fine. Remember, it's on the formula page. Okay? So 2 cosine squared x minus 1 is equal to cosine of x. Now what? Move it over, set it equal to 0 so that I can solve. So 2 cosine squared x minus, I'm going to say cosine x minus 1 equals 0. So I'll move it all over, set it equal to 0. That way I can factor, I can do all that. Many of us at this point in time, we said, okay, that's 2x squared minus x minus 1. Just wrote it a little bit simpler so that we could understand it and use that a little bit better. Okay? And I'm going to factor. So 2x and 2x. What two numbers multiply for a negative 2? And they add for a negative 1. Negative 2 and a positive 1. Don't run off without your change. So I got x minus 1 and I got 2x plus 1. But really what I have is cosine of x minus 1 and 2 cosine of x plus 1. Going too fast, everybody okay with that? Kind of ring a bell here as we're going. This is last unit stuff. Okay? Which means cosine x has to equal to 1, or cosine of x has to equal to, if I move the 1 over, divide by 2, I got a negative 1/2. Which are you going to solve first? You're going to do the 1/2 first? I'd probably do the 1 first. Just me, but it doesn't matter. I can do both of them anyways, right? Where's cosine equal to 1? Good. 0, 360. Right there. Okay? I've moved to the right in my circle. That's all I've done. So 0 or 360 or 0 or 2 pi. Okay? 0, 2 pi. Where is cosine of x equal to 1/2? Not even worried about the negative part of that right now. Where's the 1/2 part? Using my fingers. Pi over 3, it says 60. I need the 1 to be up here because cosine's up here. Sine's down here. Cosine's up there. So it says 60. It's pi over 3. Except it's not pi over 3 because it is negative. Where is cosine negative in my unit circle? 2 and 3. Which would be 2 pi over 3, 120, and 4 pi over 3, which is 240. So 2 pi over 3 and 4 pi over 3. We may have actually done that problem, I think, when we were doing it last year. Okay? So we could solve that doing there. There's 4 different answers. 0, 2 pi, 2 pi over 3, and 4 pi over 3. Okay? Now, I'm going to do the same problem again. I'm going to do it differently now. Okay? So we solved that algebraically is what we did there. Let's solve it graphically now. Can I graph that?
Yes.
Should be pretty easy, right?
Yes.
That we just did it just a second ago. Where does cosine begin?
At the top.
At the top. And it ends at 2 pi. It's got a period of 2 pi, so I'll see another high point at 2 pi. What's going to happen at pi? I'll see a low point at -1 right there. So I have that graph right there. That one's pretty easy to graph. Not too bad. Okay. How about this graph right here? If I was going to graph cosine of a double angle or double x. Okay. What is this right here? What did I change? The b value, which changes my period. So my period is 2 pi divided by b. In this case, it's 2 pi divided by 2, which means the period for that graph on the left is pi. So from 0 to pi, I see an entire graph, which means at pi over 2, I'm at a low point. So I have that right there. Well, let's go on and finish. Let's go on and solve it for 0 to 2 pi. So another pi would put me there, halfway there. So it would look like that. So there's a picture of that same equation. Now, if you had a picture, how do you solve a picture? How do you solve a graph?
You look at the intersections.
Look at the intersections. Well, this is nice. They start at the same point. They end at the same point, which is
0, 1, and 0, and 2 pi.
the 0 and the 2 pi. Those are those answers from the algebraic expression. Okay? And they intersect here and here, which will relate to 2 pi over 3 and 4 pi over 3. Now you're going, well, I don't know about that. How you do that? I don't know if I graphed as good as you did, or I may have graphed better than you did, one or the other. All right? But if I graph and I'm solving from a graph, when I sketch it by hand, that's probably not good for me, all right, most of the time, because I don't graph real pretty, all right? So let's use our calculator. Let's go through the same thing, but let's put the same idea in the calculator, okay? So grab your calculator. So I'm going to go on and start fresh. I'm going to go on. I'm going to go new. No, I don't want to save that. All right. So I'm going to go on. I'm going to go new. And I'm going to add a graph. Okay? So the graph that I'm going to add is I'm going to go trig. I'm going to go cosine. I'm going to go x. So all I did I went graph. I went right below the control. I went trig and I picked cosine and I put x. So there's my parent function. Okay? So there's my cosine graph. Some of you may be going, I don't have that. Then you may be in degrees. Because if I'm in degrees, then there's what it looks like. That looks like a really fun wave pool right there. Hopefully I get my money's worth out of that one. All right? And so if you get this right here, then most likely you're in degrees. Most of our graphs that we're going to do, we're going to be in radians. All right? Most of them are going to be in radians. It's easier. It's more applicable for our word problems. So if you have this, a quick fix is just to go up there and go radians. Now, if you're adamant that I'm going to do this in degrees, I don't like radians. Okay? Well, if that's the case, then I have to go down here. I've got to go to menu. I've got to go to window. And I'm going to go to my window settings. And basically what this is saying is I'm going from -10 degrees to 10 degrees. Well, that's not very much of the circle. Okay? So if I change that 10 right there, and I made it 360 degrees. Now I've gone one time around the circle. And so if I do that, now I get a little bit more of a graph. Now, that's a lot of work in my opinion, okay? So a lot of times I like to just stay in my standard window. Stay in my standard window and just change the radius, okay? So that's the first one, okay? I'm gonna hit tab. I'm gonna go trig and I'm gonna go cosine. And now I'm gonna put 2x in. So now I did the other side of the equation into F2. So when I do that, there is my answer. Okay? Now, here's the thing on this. How many answers are on this screen that you see?
A lot.
A lot, correct? They don't want you to list all of them, okay? So a shortcut I like to do a lot is when they tell me the domain, because they'll say, go solve this problem on this domain, what I would do is I'd go to menu and I'd go to window and I'd go to my window settings. And if they say solve this on 0 to 2 pi, then I'm going to put 0 in there and I'm going to put 2 pi in there. So if they tell me the domain from 0 to 2 pi or negative 2 pi to 2 pi or whatever they tell me it is, I'm going to match that in here. And so now I'm going to give that, there's my picture of what they want. Okay? Now I'm not providing extra answers. So the only thing about doing that is because my endpoints are also answers, it's going to be hard to find intersections, but I think I can see that anyways. So 0, 2 pi, which is 6.28. All right? So that matches. Good. Let's go find these two in here. Those are the ones that I was worried about my graph anyways, that I sketch it well. I actually sketched it better in this one than I did in the other class. All right, menu, analyze graph. I'm going to go to intersection. Get my code over here and bound that, and I get 2.09. That's not what we got a while ago by hand. What did we get by hand a while ago? 2 pi over 3. Okay? What is pi? 3. Okay? Yes, I know. 3.14, right? But it's 3, just a little bit more. What happens when I do 3 divided by 3? It cancels. It's 1. And so I have times 2. Well, I got a little bit more than 1 is what I have, because 3 pi divided by 3 is a little bit more than 1. So 1 times 2, or a little bit more times than 1 times 2 gives me 2.09. So that's right. That's 2 pi over 3. I'm pretty confident about that. If I keep going, sorry, I got out of that. Menu, analyze graph, and intersection. If I were to go over here, then I get 4.19. That's in radians. All right? So it's the same thing. It's 4 pi over 3. The pi and 3 kind of cancel. Leaves me 4 and a little bit of change. I'm in good shape. All right? So I kind of understand. I'm in the right spot here, but I understand what's going on there. Yes, ma'am?
So you want to translate the 4.19 into like pi?
It really wouldn't matter.
Okay, so
Okay?
that's right.
Now here's what I'm going to know is if I've got a calculator, I'm probably providing it that way
Yeah.
because I'm not going to transfer it into other. But I'm not going to take if I'm doing non-calculator,
Yeah.
like if I'm solving, I'd leave it in the other form.
Yeah.
That's probably how I would do it.
Yeah.
Yep. Good question. All right. Everybody okay with that? Now, I can do this with anything, no matter what equation they give me. So some of the stuff that we did on Friday where it had tangent equals 3 or whatever, then I can put tangent in one, I can put 3 in the other and go find where they intersect. That's all we're doing there. Okay? So some of that we'll have to do by hand, like we did last unit, right? But there's a lot of it that will be provided a calculator we can do in a calculator. All right? Somebody was asking in the last class, well, what's the test going to look like? Yes, you'll have some non-calculator, you'll have some calculator. You'll have a little both. Okay? All right? We're doing a lot of the calculator heavy stuff today and tomorrow. Good? All right. Let's turn now. Let's go all the way back to the very beginning of our packet. All right. So the application that we have where we can use a lot of the sine, cosine, somebody say, ooh, physics. Yeah. You've got a lot of this that you've probably seen. Some of you that have seen sine and cosine, you've probably seen in physics. But you have a pendulum, You have an orbit of a satellite. You have vibration of a tuning fork, any kind of music stuff. You have a lot of things that can be modeled by a sinusoidal curve. Sinusoidal meaning it can be sine or it can be cosine. All right. So we're going to do a little example of that today. We'll probably do a one or two more of them tomorrow as well. Okay. All right. So here it is. Give it a chance to look at this. Okay. So I've got the graph indicates the depth of water off of a certain pier in Port Aransas, Texas, beginning at noon on March 19th. T is the hours after noon on March 19th, and Y is the depth of the water from sea level in meters. All right. What I want you to do is I want you to go answer A, B, and C. So look there and see if you can go find A, B, and C. What time and what date is that? So where's the first high tide? Where's second high tide? Where's first low tide?
Does the start count as the?
Yes, that's what I would say. All right. So what time of day is the first high tide?
March 19th, 12 p.m.
Okay. Noon or 12 p.m. on March 19th. Good. That's the first high tide. That's where we're starting. Okay. When's the second high tide?
March 20th at 2 in the morning.
Okay. It's March 20th at 2 a.m. So 2 in the morning on March 20th. So that's a day removed. All right. And then what's the time and date of the first low tide?
March 19th at 7 p.m.
March 19th at 7 p.m. Okay. Could we now answer part D?
Yes.
It says, how long does it take the tide to complete one cycle?
14 hours.
14 hours. And then how do we get that? From 12 noon all the way to 2 a.m. So that high tide to high tide, that takes 14 hours to do that. Could I do that another way?
You can just look at the two top points.
Yeah, I looked at the two high ones and two high tides and did that. Could I do that a different way? Do they have to provide me two high tides?
You go to the low point and just times 2.
Exactly. So I can say, how far is it from high tide to low tide, which that's 7 hours, all right? But then that's only half the cycle, so I've got to double that and times 2, and I can get 14. Sometimes they don't provide me with 2 high tides. They provide me with 1 high and 1 low, and I can get through that one. Okay. What's the principal axis, or what's the midline here? Y equals 0. Could I pretty easily ask you the amplitude? Amplitude is what? 3. So I could go up 3 and I could go down 3. So it's nice and even right there. My highest point was 3 above. My lowest point was 3 below. All right. Everybody good there? Okay. Now let's go and take this a step further. I think we got a little bit of room at the bottom of the page. Let's go and write this equation. Because if we were to write this equation, then I could ask you any time. All right. I ask you any time, you could tell me what the depth of the water is, or I could ask you for a certain depth of the water, you could tell me the time. So I could use that equation to help. So when we were writing equations, we wrote things in the form of y equals, we had an A, we had a B, we had X minus C, we had plus D, and then this was interchangeable here. That could be sine or cosine. All right? Now, before we continue, let's go on and pick. What are we going to do in this case? You're going to do sine or you're going to do cosine? Cosine? Why cosine? Because it starts at its highest value. If you chose to pick sine, what are you going to have to do with your graph?
Rotate or shift it, yeah.
Shift it, right? You'll have to have a phase shift. I don't like that. I don't want to do a phase shift if I don't have to, okay? So because this starts at the high point, then I'm not going to beat my head against the wall. I'm just going to go on and say it's cosine. Somebody probably would like to see that, all right? Now, if that's the case, what do we know about A, B, C, D? A is 3, good. So y equals 3 cosine. What else do we know right now?
You know the period?
We do know the period. Does the period go in here for B?
No, because of
No, that we've got to do a little bit of work there, right? Remember, 2 pi divided by B is equal to the period, or 2 pi over the period is equal to B. All right? Which of those equations do we want to use in this equation, or in this situation? 2 pi over the period, because we know the period is 14. So 2 pi over 14 would be pi over 7. If you want to leave it as 2 pi over 14, that's fine, but it does reduce to pi over 7. So that's the B value. All right? Tell me about the C.
there's no shift.
There's no shift. Because I picked cosine, that didn't have a C. It's 0. So I don't have to worry about it. Tell me about the D.
No minimum. So
There's no, or it's at 0, so I don't have to add or subtract there. So there it is. That looks like a pretty simple equation. All right? It's not too bad. All right? So that equation right there explains that whole situation that's happening at Port Aransas. Okay? Anybody been to Port Aransas?
where's that at?
Nobody's been to Port Aransas? It's been a long time since I've been there. It's down close to Corpus Christi, down that area. All right? It's about a 4.5, 5-hour drive. So since I don't speed, let's say it takes 5 hours. Okay? All right? We're going to leave after school because we don't want to miss any school, but we're going to Port Aransas for the weekend. All right? So I'm going to get there about 9 o'clock. All right? What's the water going to look like at 9 o'clock when I arrive at my hotel in Port Aransas?
It's gonna be past low tide.
Okay, it's going to be past low tide. Now, I could go look at the graph, right? Or
You could just
I just plug it in, correct? And so what I could do here, if I want to know the exact height of the water, I can plug a 9 in there because 9 is how many hours past noon I am. Okay? So if I were to do that, I can go to my calculator and I can go, I'm going to go control doc, and I'm just going to go to my calculator part. I'm going to go 3. I'm going to go cosine. I'm going to go control division so I can set up my pi
You built one fence, it's really
over 7 times 9.
You should.
Yep, and everything's inside the parentheses. The B and the C value are both inside parentheses. Okay? A and D are on the outside of the parentheses. B and C are both inside the parentheses. Okay? So sometimes you might have to put a double set of parentheses if you have a B value and a C value. Okay? So I have that right there. So my water level at that point in time is negative 1.87. So the tide's going to be out. Yes, ma'am.
Where'd you get the 9 from?
That was the 9 hours past noon. So I'm saying I'm getting there at 9 o'clock tonight. All right, it's 9 hours past noon. So I have that there. So the water's probably going to be fairly calm. It's going to be out. All right. Some people like to go look for little sea creatures and stuff like that, little ghost crabs or whatever are out at that time of night. So maybe that's a good time. Maybe that's what I can see. So take my kiddos out there and we can go see if we can catch some critters or whatever. All right. If I'm a surfing person, all right, which I don't know that we surf a whole lot in Texas. Okay. But if I'm a surfer, am I going to go try to go surf right now? Probably not, because when are you going to normally surf?
High tide.
Normally at high tide. That's when the water's coming in. It's a little bit bigger waves. I got a little bit better chance to do that. Okay. Went down to Galveston during Christmas or whatever. And it's kind of interesting. You see out there in the Gulf, you see all these boats waiting to come in. All right, what are they doing? They're waiting to come in for what? Low tide? High tide. They got to come in at a high tide. They can't come in at low tide. They'll get stuck. All right. So when high tide, so they're sitting out there waiting for their turn. All right. But in that amount of time, they've got a window of time that they can come in. The tide's got to be high enough. So if that was the case, if I was going to go try to surf, all right, or if I'm going to wait for like a boat to come in or whatever, then maybe I have to, in this situation, maybe the water has to be 2 or better here. All right. What if the water has to be at least that height right there? It's got to be that height right there or better. All right. If it's that height or better, then I can maybe have a better chance surfing. I can, the barges could come in, do their work. All right. And so those people work during the night because that's when they have an opportunity, right? Or early in the morning or whatever the case may be. So in this situation here, I can take this and I can go back to my calculator. I'm going to go back to my graphing part, right? And I'm going to go over here to tab, and I'm going to go up, maybe, and I'm going to delete this out. Sorry, I'm struggling here. Try this again. All right, I got to go menu. Now that I did that, I got to graph entry. All right. All right, so I'm going to take this and I'm going to make this 2, because that was one side of the equation. And then I'm going to go to tab and I'm going to make the other one 3 cosine of pi over 7 and then times x. So I get that. Now, on the graph I have right here, only get this. That looks like not a very fun graph. Doesn't look very active. What's going on here?
Our, not the appearance, like our X.
What's this? The domain's kind of changed, right? Remember I changed it from 0 to 2 pi a while ago because that kind of matched that domain? Well, in this case, this is 6.28. That's 2 pi. But what is the x-axis standing for in this situation? What's the x-axis stand for in this situation? Time, right? So all I'm seeing is 6 hours. Well, that's not a whole lot of time. And so I might go up here, I may go to menu, and I may go to window, go to my window settings, and I may go over here to this 6.28 that I put in a while ago, and I may change it to say like 48. What's important about 48? 2 days. All right, so if I'm going down to the beach, I'm going to be there maybe a couple days or whatever. So if I pick 48 in there, then I can do that. And now I get a little bit more activity with my waves and stuff, see what's going on.
What was the y equals 2 for?
Because what I was saying is to be able to surf or be able those boats to be able to come in, that the water level has to be at least 2 meters above. So I'm at that height. So basically what I'm giving you this one is I'm giving you the y value and I'm solving for the x. Okay, make sense? And so now when I solve for this, my answers are not necessarily just the intersections, they're where?
The whole area above.
The whole in between of those 2 intersections, right? And so if I went menu, went analyze graph, and I said go find intersection, and I say, okay, from here to here, all right, at 12.1, the water is going to be coming in, it's going to be approaching high tide, 12.1. So that's a little bit after midnight. I don't know if you're a nighttime surfer. I don't know if that's a good thing or a bad thing or what. I don't know, and I don't want to be out there. But from midnight there to, if I kept going, the next part would be 15.9. So 15.9, that's close to like 4 a.m. It's like a little bit before 4, all right? Again, I don't know that I want to be out there in that at that time. But if I'm working to get those ships in, then I know I've got to like 4 a.m. If I can't bring another ship, it's like 3:50. I'm not even going to attempt to probably bring one in. We'll leave them out. So you got to wait till the next high tide, which would be, if you kept on sliding,
2.
be 2 in the afternoon the next day, right? I'm going to wait till 2 in the afternoon to go do some surfing. I'll probably be a little bit better at that. Okay? So you see what we can do here. writing these equations, they actually apply the situations pretty nicely as we go. Okay? All right, we're going to end there for the day. So what I want you to do is I want you to pick up on the 527 that we skipped the other day, like 4 through 10. There's some solving equations there, and then the 532. All right? So that's what we're doing for homework tonight. Yeah. So 527 that we skipped the other day and the 532. If you don't have a calculator, go to Desmos. Desmos is pretty good. You can do a lot of this in Desmos. Okay?